So the last example, we're talking about how to graph them. Here, I'm doing the same example, x equal to t squared minus 1, y equal to t minus 2, and t is still living inside negative 3 to 3. But this time, instead of graphing, I want to find the rectangular equation. Remember, the x equal to t squared minus 1 and y equal to t minus 2 is a parametric equation. It's not rectangular equation x equal to some y. So we're going to rewrite it as one equation involving only x and y, no more t's. So to do it, we're going to first eliminating the parameter t for one of the equation. For example, I'm going to have y, and then changing t becomes to y plus 2. By eliminating t from one of the equation, I can replacing t to the second equation. So now I'm going to replace t in x equal to t squared minus 1. So I'm changing the color. X becomes to y plus 2 squared minus 1. Okay, and that is the answer for the rectangular equation. However, we only write down we only converted the rectangular equation using the two parametric equation. We haven't talking about the interval. Remember the graph we had from the previous one? The graph is actually stopped. It's not going to be goes to infinities. So we have to making sure the same graph is going to be produced even with the rectangular equation. That means I also need to have a restriction for this case is going to be x. So I'm going to have, so since t is in negative 3 to 3, and x is equal to t squared minus 1, then when t equal to negative 3, x is going to be negative 3 squared minus 1, which is 8. We know we cannot use t equal to 3 because when t equal to 3, it's still going to be 3 squared minus 1 equal to 8. So let's do, for example, 0. When t equal to 0, x will equals to 0 squared minus 1, which is negative 1. So that tells me the real answer is going to be, the equation is going to be x equal to y plus 2 squared minus 1, with the restriction that x is going to be in negative 1 to 8. And that is the final answer with the equation and the restriction.